please help me to welcome Dr. Stephen Herrod, CTO of VMware.
Thanks. Hi. It's very strange to listen to people talk about you, sure. But I appreciate the opportunity to come here and talk about what we're up to. Maybe as a quick show of hands, how many of you have heard of VMware? Oh, that's great. How many of you use VMware software? Probably Mac users, if I had to guess. Anyway, it's really great to be here. I used to do these talks 5, 6 years ago, and like one person in the front row would raise their hand. That's very make me start by just explaining what the whole company was about. But what I thought I'd do is just give you a little bit of a flavor for what we're thinking about at VMware, a lot of things that are going on right now in the industry. And what I particularly like is, you know, in the academic world and in university, and when you're in this space, you get to use all kinds of new apps and devices. And what I found as I moved from academia into the real world, if you will, is that the whole computing environment is awful. And it's nothing as fun as what you're able to do as an individual, especially in university. So I'm actually, a lot of what I'm doing right now is taking a lot of the things that we do in our private lives with phones, with Facebook, with Twitter, with whatever it is, and try and help the world of information technology, the businesses that are running IT, understand that. So you'll see a little bit of a flavor here. I have to admit, I continually am surprised by what things are like in the business world, if you will. So just a real quick history here. Let's see if this all works. So we did start the company about 13 years ago out of Stanford, and we actually, you know, when you're in a university setting, you get 2 chances to do things differently than in the real world. You get to study history a fair amount, and you also get a chance to try things that are hard or that might not ever work. And those were really the 2 ingredients that led to starting the company. Virtualization as a concept is very old. IBM really did it in the 60s. IBM created most ideas, as you're probably learning. But what we did is we thought it'd be a cool idea from the 60s and 70s that had gone away. We actually called the original project for VMware Disco, because we thought it's this cool idea from the 70s that has to come back. So that's what we were doing there. We wanted to bring it back, except bring it to the new world where there's Microsoft Windows and Linux, and there's tons of different types of servers and PCs. And so we assumed there might be a better world for it than in a world of old mainframes that were all the same. So that's how it started. It sounds like a lot of you are a little bit aware of virtualization, but just a real quick 101 version of it. The idea is that a lot of your own desktops, a lot of servers in the real world, you install one operating system on top of it, and this operating system gets really tight. Its tentacles are all into the hard drive. And the real idea of virtualization was to cut those ties and basically make the personality of a server or the personality of a desktop be just a file. And so what we did is we take these files, and they end up having 3 key traits. One is that they are literally like files. And if you think about it, when a server or a desktop has become a file, you can email it to your friend, you can back it up, you can do all these things you're used to doing with files, but people never thought you could do them with these physical hardware things. So this basic idea of making them files has been very important. The second thing is that we've abstracted. In software, we create a machine. It looks just like a real piece of hardware, but it happens to look like the same piece of hardware, whether you're running it on a high-end IBM system or the entry-level white box PC. So by making them hardware independent, all of a sudden you can move them anywhere and they'll just power up and run. And then lastly, for the business side of things, we can ensure that they are running isolated from one another. This little virtual machine over here can't see anything going on in the other one. If you get a Windows blue screen of death in one, it doesn't take down all the others. And that in turn has driven a lot of use cases as well. So pretty simple idea. And what's been pretty exciting is that it's proven to be a Swiss Army knife in many ways. And no one ever expects all the use cases when you start doing technology. But this one truly, we started by doing one machine and making it run Windows and Linux, and that was cool. But then we realized, hey, why don't we take a bunch of machines, run them together, and do classic clustering technologies? And so what we're able to do, one of our engineers figured out, is I could actually move a live running virtual machine from one server to another, and no one out there in the rest of the world has any idea where it's running or that it actually moved. So that's led to all these other types of products where you're able to load balance as more and more people come to a website, or you're able to actually move a bunch of servers move a bunch of virtual machines down to a small number of servers and power off others for power efficiency. This core notion of moving things around has just opened a whole other set of use cases. And as a result, we started with one product called VMware Workstation, and from that time it's expanded into all different use cases. We have about 35 different products at this point. So again, a lot of startups and a lot of technology are kind of lucky and in the right place at the right time. This has just really proven to be a very broad set of technologies. And that's, very fortunately, we were in the right place at the right time, which has definitely given some just really astonishing numbers if you've been watching it for a while. We've become one of the fastest growing software companies of all time with about $2 billion in revenue last year from selling software. And that doesn't happen particularly in the enterprise space these days. And what's more enjoyable is that we've been able to build just a really fun engineering team, which I work with. We have about almost 4,000 engineers around the world at this point that are continuing to see uses for the Swiss Army knife, essentially, and going in and building them. So I have a great job is really the, the bottom line. The real dramatic thing that I found out from an industry standpoint, if you look at all of the x86 server applications that are out there, whether it's web servers or databases or anything that's out there running, as of early this year, more than half of all of them in the entire world are now running as virtual machines. And that's really amazing if you just go back in time even 2 years ago. This is clearly becoming the way that all applications, whether on VMware or not, will be deployed in the server space. And as you'll hear, I think it can happen in the desktop space as well. So this is a dramatic change going on. The result is that lots of hardware vendors are optimizing CPUs and storage and all sorts of stuff for virtualization. And that just is a nice cycle, so things get faster, more efficient. And this is just clearly the way that everything will be going as we head forward. So what's going on in the backdrop? This is where we go from the technology quickly to what's going on in industry. And especially, it's no surprise to everyone that the economy has been a bit of a nightmare, and that's caused a lot of challenges for companies. But what it all roots back to from a technology standpoint is, I don't know if you can see this picture very well, but it's a bunch of nasty wires. It actually is what VMware's first data center looked like. And it's really indicative of the bigger problem going on in IT around all the companies all around the world. There's a ton of complexity that largely comes from all these tentacles that are everywhere. If I change out a server or change an IP address, this domino effect happens and all sorts of things fall apart. And again, this is stuff I didn't get at all until I really got in and met with companies how bad it actually is. If you look at the budget for how much money they spend on technology, about 70%, these two parts of the budget, are going just towards keeping things running. As we say, just keeping the lights on and keeping things going. And only 30% of the value is going to creating new web stores or adding new capabilities to their employees' cell phones, or things that fundamentally help the business as opposed to just keeping things going as they are. So this is something, this isn't VMware at all. This is what's going on in the bigger companies that are using IT as a whole. And so, especially in a time of bad financial situations, this makes a CEO say, what in the world are we doing? And that in turn has led to certainly what made us successful early on and what I think is going to be really good for the industry and us also going forward. This is the priority when you go out and you survey CIOs, the heads of these IT departments, for what they think they need to spend money on. And if you look at it, virtualization has fortunately been very good in the top that they're thinking about. What's been amazing though is this cloud computing thing. It's moved from something that's kind of 14th on the list to last year being the #2 thing on the list. And the reason I think it's funny is that, as you'll see in a moment, you then ask someone what is cloud computing, and they don't actually know, but they know that they want it. So that's where we're actually trying to spend a fair amount of time is, what are you actually after here? What's going on that's making you drive these? So the way that I've been looking at it, again, as a individual and as many of you, I use Gmail, I use Facebook, I use all these things, and they're cloud applications. They're not running on in my house. They're not doing any of that. I don't even care how they run. I don't know how they run. And that's really attractive. And again, you have to really put yourself in the world of the enterprise where they've been building their web stores, tracking HR policies, doing all these things. But what they look up at, they hear about this cloud thing going on. And there's a lot of things that we as individuals have brought to our work life. And there's a lot of things that very interesting companies like Amazon has done with their EC2 offering. For the first time, a CEO or a CFO in some cases is being handed what we call a rate card. It actually says, you can take an application and you can run it on this service and it'll cost you 10 cents per hour. And that leads to two really awkward questions internal to a company. One is, how much do you cost? This is the CEO asking someone who's running their own computing. And then the awkward follow-up question is when the person in the technology department says, I actually don't know. So it's not only the fact that they want to be a good price, but they actually would like to know how much they're paying. So this is something in favor of the public cloud that's making a lot of people ask questions. The other thing is these rumors that go around, especially Silicon Valley. You know, I hear Google has one system administrator for every 100,000 servers that they own. You hear these ridiculously large numbers, and that also leads to these same awkward questions. How many people do we have running this IT infrastructure that we have? So there's an aspiration to be able to do things more automated in a more hands-off way, and this cloud is ascribed to being able to do that, whereas their current company can't. And then lastly, this is the one I'm most passionate about. Again, you all might not know how bad it is out in the corporate world to some extent. At home, if I want to buy a movie, I click. If I want to get an app for my iPhone, I click. If I want to sign up for a new web service, I type in something and I have it instantly. In the work world, it's still the case where you request something by filing what's usually called a service ticket, and then you wait, and you wait. And I actually track this everywhere I go. For instance, if I'm a developer and I want a new web server, because I'm just going to put up a nice, I don't know, a nice web page for my internal folks, it can take as many as 6-10 weeks, something like that, by the time they go through the process of procuring servers, getting permission, getting the sign-off from the people, delivering it, wiring it up, all these things. So that the notion that I can do things instantly in my home life and in this cloud thing, and it takes me forever in the work world, is so frustrating. So anyway, these are all the factors that are coming into companies and making them say, there's something to this cloud world that I've got to capture. And now this is the stuff that really is the kind of in defense of the way that things have grown up. On the corporate side, all this stuff is great, but what they actually lose their jobs over are system outages. So if the store that runs the core business of a company goes down, they want someone to fire, essentially. Similarly, security, this is usually the number 1, 2, and 3 reason why people are worried about this public cloud thing out there. What happens if some other people can read the mail of my employees? What happens if data loss happens where all these credit cards go out? We read about these every single week of some kind of leakage that happens. So that's a critical issue. And then the third one is something that's the most boring topic you'll ever hear about, which is certification and compliance. All of these things going on in the government right now are forcing people to be able to prove whoever had access to certain data, to show that healthcare patient records have never left the state of California. All these different rules around compliance are simply not, people can't figure out how those will work in the world of the cloud. So that's kind of a long-winded way of saying there's this siren song as I think about it. A lot of great stuff that everyone wants to get to, and a lot of concerns, though, that as they look at how they're going to get there, really hit them. And so with that in mind, a bunch of industry standards people went and tried to define what is this actual cloud computing thing. And I definitely don't want to bore you with the specifics of the details here. But they tried to figure out the core traits that would make something cloud computing like. But I ultimately just think about it as 2 big things. One is, on the technology side, you need to do some form of virtualization, whether it's VMware or not. You really need to separate the concept of where things run from what's running. And that's just a core concept. And you have to make it efficient and self-service, all the pieces that we just talked about. But what's really interesting, and again, this is something I haven't fully grasped until I met with so many different IT departments. It's also a way that the world of enterprise computing changes. I think the enterprise computer departments of the future are going to look a lot like the service providers and the cloud providers of today. It'll be a very different model from this file a service ticket and then wait some number of weeks. So I'll go into this in a bit more detail. But what I really also wanted to tee up here and what we're seeing everywhere is that I always traditionally thought of cloud computing as being something that runs somewhere else, outside of my company's firewalls. But what's really happening in the industry is that they want to make things that are running inside your company be more cloud-like. And you want to be able to leverage all the great software as a service and all these other things that are available outside there. But what's very obvious is that there's going to be what's called private clouds by the industry, and they're going to be public clouds, 2 different types. But what's incredibly obvious to people now is that this job of being a CIO, the person who's responsible for all your applications and all your data, they're going to have to be concerned with both of those. And that is just very different from where they are today. Today, a CIO thrives by owning and touching everything that he's held accountable for. All right, so let's get on a bit more into the technology side of things. That's the backdrop of what's driving this notion of cloud computing. But let me give you a flavor from a VMware perspective, the way we're looking at how do we deliver this thing called a private cloud, and how might it look. And without going into all the details of the products themselves, pretty much all of the servers that go out these days, new servers that are being delivered, are virtualized. which means they are able to have multiple workloads running on top of them, multiple virtual machines. But it also means that they are actually not individual servers. You don't think about server A that's sitting in that space in a rack. You actually think about, hey, here's a whole cage of servers I have. It's not one server, it's 10 servers, and on the aggregate they have 100 CPUs and they have 5 terabytes of memory. It's about pooling all that horsepower together and then doling it out as people need it. In contrast to what it is today is, I have one app, I need one server, and if I need a new app, I buy a new server. So that core separation of the horsepower that runs things from when you consume it is the core of these resource pools, as the industry calls them now. The other area I'd love to talk about, maybe in question and answer, is that when you recognize you're moving to this model, the way you define servers and the way you build them changes dramatically. Some of you might see the things that are going on with servers that are calling themselves converged infrastructure. What that really means is that the notion of having a storage thing over here, networking switches over here, and servers over here is changing pretty dramatically. Things are being delivered all in one box. And whether it's Oracle with their Sunwork, Cisco and EMC are doing things, HP and IBM have their own world. The notion is that if the whole world's moving to this resource pool model, you can change hardware and make it more efficient for it. So for me, coming from a place where I used to beg anyone to allow hardware to work with our product, to now having the industry designing hardware just for it, it's been a very big shift. And then the other thing I think we can talk about later if we have a little time is that even the things that aren't traditional servers, things that are doing spam prevention or load balancers or firewalls, traditionally these have been these big metal devices that you plug into part of your data center and you physically route traffic through them and they do a lot of things. We're actually seeing, just in the last year, a world where all of these things that used to be hardware appliances are actually moving into that same software infrastructure. And we've been calling these virtual appliances, but I would predict if you look out 2 or 3 years from now, whenever people go out and buy what were traditional hardware appliances, we'll have at least an offering that is just a virtual machine that you just plug into the same environment. It's very exciting the way that's all coming together. So you have to start with this fully virtualized data center. And then on top of that is something that is, again, very obvious to us as consumers, but just not at all in the corporate world. We all use app stores of some kind now for almost anything we have. It's a place I go. I get a menu of things that I might want to do. I might even get some reviews on how well they work. And I literally click, and I can get it delivered to my iPad or to my Android device, whatever it might be. The big transformation going on in the corporate world and in the data center world is exactly the same concept. Today it used to be I would order a server and then a raw server with a network. I'd get an IP address. And then it'd be up to me to actually install an operating system. And maybe I want to write a Java application. It'd be up to me to install the app server and the Java and the JVM, that sort of thing. But what they're realizing is that in this world where, as we went back to the very first slide, where you have servers that have become files, what you can do is just create these online stores. And it's just these files that you can literally grab one, install it to a server. You don't have to install drivers, anything like that, because it is hardware independent. And instantly you're moving with exactly what you want. You're not just getting a server, you're getting the exact software in place. So this is a massive transformation on the side of companies, which I still find very amazing, just given how much we're used to it in the personal world. And then the last part is, again, something that's very different. By really focusing on the same experience we're getting as consumers around user access, companies are realizing they should do the same thing. And that certainly, as you'll see in a moment, it's about logging into a web page, seeing all the things that I might use as an employee of this company. But what's really been dramatic is this notion of chargeback. And the way the world works right now, no one really knows how to charge for all these computing resources that go on in the enterprise. Sometimes people will give you, anytime you want a new server, you just need to give me $3,000. Or they might say, we're actually building this new data center. All of these departments that make up a company, finance and engineering, each of you owe us $25,000 to help us get moving on this. What companies are being able to move towards with this new model is exactly what we're used to in the electricity business. I get a bill at the end of the month that says I use this many kilowatt hours, and I get a bill that's proportional to that. Again, this isn't rocket science, but it's not the way it works in the industry, in the enterprises today. So with virtualization and with this notion of cloud computing, they're now actually able to do what's called chargeback to their employees and say, you actually use this much of this nice corporate resource, here's what you should be billed for. I also wrote this thing called Showback. This is actually something that's very funny also. And again, it didn't make sense to me much as an individual. But what happens in these companies is that you have an employee or a group spin up a project. They might have 10 web servers that are running something. The people might get fired, or they might quit, or the project goes away, but people forget to ever turn off those servers. So you get this world where you just have this sprawl of servers and things that are running there. What we found as a side effect of this cloud world is that when you get a bill at the end of the month that says you had 500 servers running on an average of 12 hours a day, all of a sudden they have visibility and they're able to actually change things. And again, you'd be shocked at how often this happens. The number of, I call them zombie servers out there. They're just running, not doing any useful purpose, but taking up space and air conditioning. It happens everywhere. So again, all this seems a little bit ridiculous, but it is core changes that are going on in the way enterprises run their data centers. This is just a picture on how the world works in the new world. Again, this looks exactly like what we're used to as employees. I can now, at my company, or at Chevron in this case, I can log in. I'm a developer in engineering, or I'm someone in finance, or I'm someone in HR. Instantly, I'm given the set of applications that are readily available for me to use. I'm also given something for the first time ever, which is a price. You can actually run this thing for X dollars per month. And same things you would do in real life. I say, I click these two, and the next thing you know, I have access to these servers in a very nice way, and they're very consumable. So this is definitely the direction that companies are going as they create their private clouds. And again, you can't appreciate enough how different it is from where the world is right now until you really get in and look at it. Okay, so what I really wanted to do here is talk about not just how the data centers are changing and not just how virtualization is making things a bit more like our consumer life, but I want to talk about two other areas that we found as a company that we've been able to move into by starting with the same concept. And the first of those is really thinking about applications. And again, in a university setting, the world is fairly different from the way it is in a lot of these big companies right now. So, honestly, a lot of the applications, particularly in big companies, are still these kind of ugly web servers that are attached to really old databases. And it takes a while to get features into them, and they're not fun to look at. There's nothing that even remotely resembles things that we see in our personal life. This is my Facebook friend if you want to friend me later. So the idea is that this is what I look like, or this is what I look at when I'm at home, and actually this is far better than what I look like at work. But it's like a text screen with nothing interesting. And the thinking here is that the people that are building public cloud applications are really giving a hint moving forward for what people that are writing enterprise applications should look like. So there's a lot of traits about these existing apps that we're working with as consumers. They're very easy to use. It's always about collaboration between multiple people. Certainly you can access it from a web browser on whatever device you have to have. This sounds very, very obvious to all of us in our personal life, especially in a university setting. This is what we're used to, so far apart from what the world is like when you're actually working with traditional applications. So our theory was maybe there's something in this virtualization thing that will help us accelerate the world of the enterprise and moving towards this new world of applications. And there's also something very interesting going on at the same time. I might date myself a little bit. When I was writing, learning all my application programming in school, I was writing, I'm doing system calls in Linux. I'm writing to the Win32 API. I'm actually writing pretty directly from the application to an operating system. But there really have been these two big changes happening right now. I just told you now that more than 50% of the server applications in the world are now running on virtualization. They're actually not even talking directly to the hardware. So that's a dramatic change from how things used to be. But on the application side, a lot of you taking classes, whether it be in Java or PHP or Python or any of these things, recognize that you're not writing applications directly to the operating systems anymore. You're writing them to these much more productive frameworks that are doing a lot of the work for you. And it's really changed the approach on a number of fronts. We've been able to use all the new CPU power to bring more efficiency and richer apps. And also you're able to make them more portable. If I go out and write some sort of web app right now, I don't know, or frankly, I don't care at all what are the versions of all the stuff running under it. I don't know if it's a SUSE or a Red Hat or a Windows application in a lot of cases. So this has really transformed the way that enterprises who are just kind of catching up with this are having to think about the world. And the opportunity, I think, that happens here is that I'm now writing to a higher level application framework, and I'm able to combine it with this virtualization layer. We've been really thinking about how we can make things very different by those two being combined. So let me give you a couple of quick examples. Actually, our biggest acquisition that we did about a year ago was a company called SpringSource. It's an open source framework for Java called Spring. They own Tomcat and some things that some of you might be aware of. But they actually got into the business of making Java a lot simpler, and they have about 3 million people writing these programs. We had this theory that, okay, people are writing simpler programs in Java when they go to this world. Could we combine that with the virtualization layer to do things in an interesting way? So I just wanted to give you a little taste of this. Also throw out some acronyms that you're hearing all the time. The thing that we're really providing right now with virtualized services and things like Amazon EC2 service, these are giving you what's called infrastructure as a service, which is a terrible name for just saying, I want a server, give me a server. But when you actually start talking about application frameworks, there's a term that some of you have probably heard called platform as a service. What that means is I'm no longer asking for a machine. That's not the way I interact with something. I just want a programming environment, and I just really want to write my Java app, and again, I don't care what's underneath the covers. So we think that there's a world where we can change the way that enterprises build their applications to recognize that all their developers really want to do is write applications that sell more products for their company, and we have this great stuff underneath the covers to help with it. So again, let me give you just a little flavor for how things work as you get to big enterprise applications and why this might change. Let's take this for a moment. So, when we write small applications, in your programming classes or even personal things that you're doing, you don't have to think about, what happens when 2 million users hit them at the same time right before the holiday season. You're able to really just think about the logic. But when you're writing these things for an eBay or a company that has just a lot of scale, there's the logic of an application, and then there's all this gross stuff underneath the covers. There's a load balancer that chooses, how to redirect these things as loads come up. You might have 10 application servers and a few web servers underneath that. And then always the most complex piece is there's some kind of connection to a database or mini databases. So what looks like a simple application when you deploy it to scale usually has 10, 15, or 20 nodes underneath the covers. And what's worse is that when something goes down or when a big rush of people come on board, you manually go in, you add a new server, you wire it up, you maybe edit a table in a load balancer. There's all this work goes into making it be able to scale. Well, what's really cool in a virtual world is that, again, there's no physical stuff involved. For me, the equivalent of plugging in a new server and adding it to the pool of things that can serve web pages, it's literally copying a file. I can literally just clone an app server, and all of a sudden I have more horsepower. So just as one example to get you thinking, if you can really have that type of orchestration control over things that are coming out, then I can actually make a web server that's constantly tracking how long the response time is to any of us who are trying to buy something, and automatically change things on the fly to be better or worse. So if no one's actually buying stuff, I shouldn't be wasting all the space in a data center, and I shouldn't be wasting power by having servers on. But as the rush comes on board, I want to be able to handle as much as possible. And that gets to the core of a lot of the waste that goes on in companies. Almost everybody is used to sizing things for peak demand. You want to have everything in place for that great opportunity when you have a ton of people who want to buy your beanbags or whatever you're selling. And you're willing to pay a lot of the cost of having this stuff sitting there idle in exchange for being able to reach that type of users. So the real concept of this notion is I can actually have all the benefits of scaling up and scaling down very quickly. Lots of other interesting things that we think can be done in this world. Another example is that when you're watching the performance of some kind of web application that you write, it's very easy to see what part of your code might be running more than others, doing classic profiling that a lot of you do. But it's another thing to actually be able to combine the profile of where time is being spent in your program with real data about what's going on underneath the covers. How many network packets were coming in when I'm writing this piece of code? How is it accessing the disk? So another thing we're looking at is how can you give visibility into everything that's going on as you try and do this? So again, we can go into a few more examples, but the main walkaway is that if you can combine this power of these new application frameworks with new types of underlying hardware, if you will, that it's actually virtual, you can do new things. And so what we're seeing companies do now is offer up internally, if you're going to write the latest application for GE, here's something where you don't have to request a server or anything. Log into this site, upload your jar file if it's a Java application, and it'll automatically get going. And that's very disruptive for the way they do things. But what we're also seeing is that people looking to build the next generation of SaaS applications. So this will be the last AAS thing that I talk about. So most of you probably know that software as a service is yet another way of consuming something that's running out there. This is about getting servers when you want them. This is about getting a programming environment when you want it. And this is ultimately what matters, which is I just want to run an application. Gmail, I just want to get my email. I don't know anything behind the covers, but I get to it. So what we're now also seeing as a very interesting world is you can actually get all the next companies that are building these software as a service applications to use these frameworks, and they automatically get automatic scaling and all these things that they want. So we think this will be a pretty big way that people look at all sorts of new properties going forward. So I did want to talk about one other thing quickly. I don't know if any of you are using some of the platforms as a service that are out there. There's some good things that are going on. Google has something called App Engine with a few different layers of programming on it. Salesforce.com has something called Force.com, and that's a way that you can write applications for their platform. But there's been a real challenge around these notions of writing applications for the cloud, and my boss calls it the Hotel California effect. The lyrics are a little bit wrong in the song, to be honest, but he says you can check in, but you can never leave. And that's kind of what we're seeing as the real part around the cloud that's concerning people. Right now, when you write an application for one of these platforms, you're stuck there forever. So if I start to build a business on, we call it Force.com, I've written things that are very specific for that implementation. I can never pull it out without rewriting my application. So one other really interesting thing that we've been doing is looking at how we can actually have a common way of writing cloud applications. So we launched a initiative with both Google and with Salesforce.com to create new types of cloud programming models. And again, this is something that doesn't hit you when you're writing smaller applications, but when you begin to write big applications and bet your business on them, I actually want to be a developer, and I'm writing the logic about a particular type of application. And literally, I want to choose from a menu. Okay, I want to deploy this to the Google App Engine Cloud, which is going to cost me this and have these traits. Or, I actually want to deploy it to my company's cloud, where they're actually running things inside the data center. Maybe it's more secure or has access to new data types. So if you think about really what's going on here, though, is the ability to abstract the logic of an application, what you're really trying to do with it, from both where it runs and how it actually is operationalized as it goes forward. And this is something that's also very disruptive from the way that people do it today. So we can go into that to a little more detail if you like. But think about it, I think about it really as virtualization just at a different level. We're abstracting the logic of an application from how and where it is actually deployed. All right, just about 10 more minutes. I wanted to touch on my favorite area, which is the thing that really touches all of us. How do I actually interact with computers myself? That's great that your data centers are efficient. That's stuff that's running back behind the firewall, and it's nice to program, but what do I use? And this is something I definitely realized as I went from my happy world at home where I had 3 phones and 2 laptops, and I literally had all these great devices. I use them however I want. Typically, you show up at a company and they say, you can use exactly this lame laptop, and it's ugly and it's slow. They give it to you, and that's the only way you're allowed to work at work. But what's very clear is that, especially now as a user, I want to use all my devices. I want to work from home. I want to work from an internet cafe. I want to work from from work certainly. And if you just look at the history of IT, there's always been the struggle. Anything that gives users more freedom is more of a pain for IT. And you'll hear about this everywhere you go. This is why they don't like all apps supported, why they have specific laptops. So we thought we could use these same techniques we learned about in the other parts of our business to attack this problem. And this is my favorite picture. This is like a lame old PC that you might get at work, probably about 10 years ago actually. But the idea is that people have really been working, and all of the IT processes that are in place focus on devices, which is really broken if you think about it. It used to be the world that, like, even if you think about the term desktop, what does that mean? It used to be you had a desk, a physical desk. There was a PC that sat on that desk, and if you wanted to work, you'd go to that desk. It's like it's a physical thing that you're going to. But obviously right now we don't go to one place. We have multiple devices, and what's very clear is we want a model where it's more focused on the human. In fact, the way we focus on this is that devices, especially these days, kind of come and go. You might have a new phone every couple of years, every year, a new laptop every once in a while, but hopefully the human stays after that. So we really want to think about a world where you're installing software, if you will, to a human, and you're not installing it to a device. So we've taken a couple of different approaches to thinking about this. The first one is something that has actually been taking off pretty rapidly in the industry as well. You know, for Windows applications, which is still the bulk of what companies are using, you shouldn't actually have Windows installed on a specific device. In our opinion, you should actually install it into the data center or into a cloud, and then you should be able to access that Windows application from wherever you happen to be. A lot of you have probably used things like VNC, or on the Unix world, there's X Windows. There's these notions of accessing things that are remotely. And what we're trying to do is make that go mainstream for Windows. So we've done a lot of pretty interesting work to make sure that whether you have a traditional laptop, or you might have a thin terminal, just a dumb terminal in many ways, or even an iPad or a phone, you should be able to access your personal Windows desktop from any of those devices. And what's more is you should be able to access them from anywhere. Whether you're over the WAN or the LAN, you should get access to exactly the apps you've installed, all the data that's there, that Word file that you're halfway done with. And that's been a pretty dramatic transition going on here. What's also proving to be the case, again, more unique to the enterprise than to personal life, is that it's really hard for enterprises to move between versions of operating systems. If they're going to move everybody over from Windows XP to Windows 7, they have to port every single application, make sure it works. They have to train all their folks in service, that sort of thing. But what this also allowed people to do is mix the types of versions that are going on here. All new users might get Windows 7. All old users get Windows XP. So this is cool, and it's actually helping on a number of fronts. It particularly helps on places where they want data to stay in one place and not go out on laptops. But the number one problem all of us have when we're on any kind of networking computer is what happens when there's no network, or a crummy network. So I travel a lot, and this just wouldn't work for me because I need to be able to work when I'm on a plane, for instance. So one other cool thing that we did, going all the way back to the first slide, is these desktops and servers are just files. And what's more, they're completely hardware independent. So I've got my cool, fancy new Windows 7 desktop that's actually running in my VMware data center. I attached to it over our network, and I have a good life. But now I'm about to get onto a plane. What we're able to do now, actually, is check out the virtual machine. So literally, I press a button at work, and I stream this file down to my desktop. And I go to a plane, I can install new applications, I can work on the data. And when I get back into my office, it's just going to synchronize that back into the cloud, back to the things that actually changed will go back there. So what this really lets you do is make these devices actually be caches, if you will, of that personality, of that thing that was installed to you. And this is just now starting. We just shipped this in the last couple of weeks. But we think it's going to be a pretty dramatic way for moving even more people towards a world where your Windows desktop is running somewhere else. So that's pretty exciting. But what I really like is that this is actually hitting at the perfect time for a problem that's hitting every IT person in the world. If you go to CIOs at these big companies, they are getting so much flack from their users for giving them that lame, heavy old laptop that I was talking about. Why do I have a cool Mac at home? Why do I have the latest technology there, and yet I go to work and I have to use something else? So there's something really cool going on that I've been referring to as bring your own PC. Today, if you get a job, often what happens is you're issued a work-approved lame laptop. It's usually lame. And what you have to do then is get everything to work from there. This is a pain for you, but it's actually a bigger pain for the IT department. They actually maintain a big inventory of that old ThinkPad or whatever it might be. And they're responsible when it breaks or when you drop it for getting you the new one. They've all of a sudden become someone who's in the inventory business, which is just a pain. So the ideal world for the companies is that they actually give you $1,000 a year or $1,000 per 6 months to buy whatever device you actually want. And then it's up to you. You can choose whatever you want. You can go replace it whenever you want. And they'll let it work in the corporate environment. And so we see a great opportunity here. This is my Mac with my little iTunes world going on. But I show up at work, and they can issue me the work-approved virtual machine. So in this case, I could either attach to it over the network, or I could get a DVD with it. And now I've got my Windows 7 environment that has all my work applications. It has VPN so that it's safe access. And it does two really good things here. One is that they know exactly that when I'm touching the corporate world, it's through a world that they know how to support and that has all the stuff that matters. And what's also the case is I can now do all my fun stuff outside of this without carrying two different devices around. So it's the early stages of this, but if you just step back and think about it, the idea of having multiple personalities, your home life and your work life, that can be kept very separate, but it doesn't have to mean that they're inconvenient. That's something we can really attack here. We'll be announcing soon doing something very similar on the mobile phone front. So we've realized that a lot of these same things hold very true for phones. Literally in the corporate world, if you ask the number of people how many have a work phone and a home phone, and they literally carry the two around, it's astonishingly high. So you'll see us doing some interesting things around phones where you show up at work with your cool new Android device, you'll be issued the work-approved phone, and on the side you can have your home phone. And you actually have two phone numbers. You get like a cool ringtone if it's your home number. You get a work-appropriate ringtone if it's your work phone. And just think about it that way. You can really begin to combine different personality types and different roles onto a single device. So very excited about that part of it. I thought I'd just pull it all together, just one example, since this is a university setting also. I want to give you one example that people are doing that pulls a lot of this together. And I have a side passion for education, certainly, and for figuring out how to make it better. If you watch anything in the news today for California or Illinois or Ohio, budgets are a disaster. You just can't buy things for students right now, especially at the K through 12 level. So we got to thinking, could we pull together all this cool stuff we've been talking about and somehow make a difference? So I thought I'd just give you a real quick example to make you think about this. So this is the state of Illinois. And what happened right here is that a lot of states, California included, have spent a lot of money putting high-speed networking in place. In fact, they launched something in Illinois called the Century Network. And California has a great one as well. It's a high-bandwidth backbone that connects all public schools and actually a lot of the public government businesses. And it's used for a lot of stuff, certainly for doing some video conferencing and voice over IP routing, stuff like that. But we and other people got to thinking, wow, why don't we use this for even more? And so what happened in Illinois, and this is very early stage, all the schools had their complete technology budgets cut, especially at the elementary school level. No way to buy a new PC, no way to even maintain the ones that they had. Someone got this cool idea to create what I've been calling a cloud co-op. And if you think about like a grocery co-op, everyone is submitting a certain amount of money each month for some share of the overall thing that they're trying to build. So this has enabled all these school districts to actually pool their very small amounts of money and create something they're calling the Illini Cloud. And then what this has allowed people to do is all these, whether it's a small rural school way out in East Illinois or whether it's a big one in Chicago, they could choose to begin running any of these things that they're running in the schools. On the server side, it could be, I don't know, I found out there's big applications that schedule school buses. I didn't know that, but these are applications that the data centers have traditionally run that they could move here. And on the student front, whether it's a young kid using Reader Rabbit or someone who's actually doing new programming models, they can replace these computer labs that they have or don't even have. They can put in literally a dumb terminal, just a flat screen, and tap into the same cloud for running all those applications. So it's very early stage here, but what I have found very neat is the notion that this type of cloud model allows you to pool resources. You could have a lot of different places that are cooperating together. And just like any other form of economics, when you have a bigger group that's pooling their resources together, sometimes you can do something in the middle that is a lot more efficient than any one of them could do. So again, this is very early stage, but it's an example of things that I'm seeing that I think could be quite exciting for ways that we use the cloud as we head forward. So I think I'm just about out of time on this front. I hope this is kind of an interesting overview of what we're doing. Kind of a quick recap is we certainly started with virtualization, and we thought it would make an interesting first step towards Linux and Windows working together. But as you can see, once you build a core technology, there's really the chance to expand it to do things, in this case, not only in the data center, but in applications and desktops. And I think you'll see more things as a future, from phones to who knows where else it goes. So thanks, and I guess you want to do a couple of questions?
As someone whose life kind of centers around the cloud right now, I use Gmail, I use Google Calendars. I'm kind of attached to the cloud. I'm excited about it, but the one thing that concerns me is when I'm watching these projects, I fear for the future that all of our things aren't going to be something that we own. We don't own applications, we'll always rent them, and then we'll forever be put into those situations. Is that really where we're going, or do you think it's going to be like we would buy Photoshop, we'd own Photoshop, but it's still available to us on the cloud?
Yeah, that's a great question, and I'll answer it a couple of different ways. So one is, some people are living entirely in the cloud today, and candidly, someone who starts a startup today, they don't build a data center. They go grab stuff from all these different sites. But you're right, it actually has caused people to realize that they've just bought into an annuity model. You're essentially renting your life. And this is the same when you choose to lease a car versus buy it. So increasingly, we're seeing companies that start that way, and then they recognize some of the benefits to owning all their own infrastructure. And honestly, what I've seen is a nice boost of energy on the non-cloud side of things, where IT departments are now finding themselves in competition with a Google or with an Amazon model, and that's causing them to be more and more efficient and offer more things to their own constituents. So I think there's a lot of interesting things on the business models and on who owns what that are going to be important. More than applications, though, data is where almost everything's at. There's enough publicity to cover privacy problems and where things are. We have a side theory that we're working on, which is data as a whole. All of us have all our stuff that's running different places, and a lot of people have made the analogy that data should actually become similar to money, where there's a lot of reasons you want to keep money to yourself and always be able to spend it. But at least if you're going to put it somewhere else, you should be paid for that. You should get the equivalent of interest. So we're also thinking about this world, maybe all that data that you have about what you buy and who you are should go to a data bank. And then you're able to actually control who has access to it more centrally and maybe make some money as a result of people mining it for marketing data. So I think this is the technology side of things. The business and the things that change by not owning your data and your apps is going to be pretty dramatic as well. One other thing, if I could, the other part that I didn't exactly hit on here, and again, I found it very different as I moved from my home and my university life to company life. Everybody in computer science has always talked about nirvana, everything will be perfect. But, by the way, throw out everything you have today and rewrite all your applications. The way we're really seeing it is that companies, actually most of them want to get to this world of where most things are in the cloud or where things are very safe, but they have 10 or 12 different applications that are in-house. So the really interesting thing about, I think, virtualization and a lot of other technologies is not the end state so much as the gross details of how you get from one to the other. And that's also something that's a lot of companies are asking for, is how do I get to that end state you're in, but not throw out everything.
Question?
So with the release of the vCloud Director 1.0 and the vCloud API 1.0, this VMware 2010, how has the cloud computing and the management of the clouds has changed the industry? Like how industry are using that to leverage the cloud computation and the management of it? And the second question for you is like how the student body can take advantage of cloud computing in their academic projects. We know that EC2 offers clouds to their student body with a discounted rate. So is there any project going on in VMware so that student bodies is benefited with that?
Yeah, two good questions. Let me start with the second one, which is, one reason I'm here, and a big thing that we're ramping up at VMware is our academic programs. In fact, we have some of our leaders here. We see the exact same thing. So we're actually working on a project right now that hasn't been fully released yet, which is, I'm calling it EduCloud, but essentially is just a way to offer, probably first for students like you all who are doing more engineering work. We can make it very easy to distribute programming problems as virtual machines, to submit them for your automatic grading, as virtual machines. And also, instead of having a physical lab that you have to go to, why not access that exact thing from your browser wherever you are? So we're definitely doing that. Actually, love to talk with this university in particular about some programs we might try. The other one is, so very deep in our product set. We have like a lot of companies, we have a fairly big user conference, and we just launched a big set of things for us, which is really around delivering this model that we talked about here. Again, most companies don't have any notion of an app store. Most companies don't have any notion of letting a user actually type in a password and be presented with a set of things they could do. So we did launch something that you referred to called, we call it vCloud Director. And if you haven't noticed, everything VMware ever does has a V at the start. So you can always tell what we're up to there. vCloud Director is exactly what we're shipping to companies that want to offer up this cloud service, kind of like that Chevron picture that we showed. Now, one just quick side point that I didn't go into here. Our strategy is actually kind of interesting. We have about 190,000 different customers, from jelly makers to car manufacturers, that are running data centers based on VMware. But more interestingly is that we're getting a lot of these big telecom providers and folks like Verizon who are building public cloud services based on the VMware technology. So we have this great theory that we're panning out right now, which is what if I could just make a user not have any idea if they're running in their company's private cloud or their public cloud, and they'll have this exact same interface like we showed you on Chevron. So we're really working on what's being referred to as the hybrid cloud and abstracting completely from a user where their stuff is actually running. And that's a key part of the vCloud Director as well.
I have one question. I started to use the virtual machine quite a while ago when it was available in the IBM environment. So obviously, make a lot of progress today. I have a question here. Is that you were talking about the software applications, right? So it can be integrated with the cloud. However, let's say we have a situation. One application was initiated, and then apparently there's an error in that application, and was not detected. And then the application got duplicated through the different kind of virtual environment, and have multiple users started using it. So they all have this kind of error in their application. How do you control to eliminate those kind of errors? What kind of thinking, currently is being used?
Yeah, I think the question was, so how could we help with application correctness? And I guess also, I think you're implying that if you distribute one virtual machine, it could virally become a lot of different ones. It's actually, so I certainly on the engineering side came from system programming, where I was thinking, how could we make programs run better in this world? There's a couple things I'll throw out that you can see if they answer the question. One thing I found, for instance, every virtual machine in the world running on VMware in Windows has the exact same hardware, virtual hardware, if you will. So one example of how things have worked out well is that the drivers in Windows that talk to our virtual hardware are the most heavily used drivers in all of the industry. Every single virtual machine is talking through this particular SVGA driver or whatever. So we've actually found that the drivers themselves that are used in virtual machines have been more correct than those that are written to physical hardware. So that's helped correctness in general. But what's more interesting is we do think virtualization at the very base level is really neat, because you see every single thing that goes on anywhere. You literally see every instruction, every interrupt that comes in. And you can do things in that world that really help on correctness that you can't do in the real world. An example, if any of you are doing any types of parallel programming, the lack of determinism in an application is a big pain. They call these things Heisenbugs. You look at it and it goes away. You can never reproduce it. In a virtual world, you can actually make things completely deterministic. And so we've actually created debugging tools as an example. And we've even done automatic checkers that can look for race conditions, for instance, just by having sheer access to all these different events that are going on. So I'm not sure if I totally answered it, but we definitely see a world where the virtualization layer can make it more correct and can give you more tools in diagnosing what went wrong.
For sure, from the system point of view, system software point of view, in order to make an application to work in the virtual environment, certainly I can see there is a necessary integration between the application and the system software on the bottom of that. They need to be work together, so you can facilitate those kind of debugging type of the processes.
Yep. Let me give you one other just quick example. This is a really fun thing that we do as well. So the bane of existence is a customer who says, I have a problem with my application, and you'll never find a support world that doesn't say, well, I can't see it here. So another example that we've been able to do is someone's running something in a virtual machine at an application level. They report a blue screen of death or an assert fail or something like that. We can actually take an exact checkpoint of the virtual machine, which means a frozen point in time exactly where it happened. And rather than calling into a support desk and saying it dies when I do this, you can actually send them a checkpoint of your virtual machine. And so what it's actually done too is allowed people to find really latent problems and debug them just by getting the exact scenario that failed over to the developers who are working on it. So it's a really neat area. I'm optimistic.
I agree.
Yeah. On the second to last slide, you were mentioning you applied that cloud to the state of Illinois. I just wanted a question. Do you know if this cloud will have will differ in a significant meaning when it's applied to other U.S. states?
Yeah, in fact, we talked about this. We had the California Secretary of Education over to VMware last week, and she was livid that I would use an Illinois example. Let me just give you two other pieces of color behind it that, again, are very non-obvious to me when I got started. So one is that in general, teachers don't like to be told what to teach. Maybe I could, I could get the instructors here to confirm that. So a lot of different states have tried things like this, where they say, here's the new curriculum that all of you shall teach, and here's the exact textbooks, here's the programs you should use. So what I've actually found is that, you know, heterogeneity and diversity and choice is the enabler for letting people feel comfortable with new technologies. So in Illinois, we actually have allowed, the people who are running it have allowed teachers to bring whatever applications they have in there and run. It's a big state with a good network, and they have a lot of the pieces that we could do in California, but fundamentally it comes down to the teachers wanting to use it and accepting it. So I think there's things that will absolutely be unique to the state and to the teachers and to the environments, but the ability to allow them to choose what applications are there is going to be the thing that makes it common.